All right. So this is question number 1. So we have this is just current and Ohm's law. So first question here, we're looking at current and Ohm's law. So we see a graph here that's giving us voltage versus current for a given object, and all we're trying to do is calculate that resistance there. So to do that, we're just going to use Ohm's law. V equals I times R. And so we need to pick the value. So since we want resistance, we're just going to find some sort of value here on the chart, and I'm just going to grab the end point there, but any point will work. And I can see that the voltage is 12 for that and 3 for that. So then you plug it in. 12 equals 3 times R, and so R equals 4 ohms. Easy enough. Any of the points would have given you that result. All right, and so then on the graph, draw a line for a wire with twice the resistance. Well, so you got to think about this. So sometimes it's steeper, sometimes it's less. It depends on what is on each axis. In this case, it's voltage and current here. And so the line is going to be less. It's going to take more volts to get a given current. So it's going to be down below it. But you also could just plug it in, right? You could double the resistance and see what your new current or voltage is for each of the numbers and just plot some new points. In this case, though, you're only going to get 1.5, 6 volts, or excuse me, 12 volts is only going to give you 1.5 there instead of the other. And so that line would look something like that. Right. So we did a similar Ohm's law. Now we've got current versus voltage. So we flop these axes. Remember I said, make sure you're looking at the axes to see what's what here. Since the wires are identical except for their length, which wire, R1, R2, is a longer wire? So we need to figure out what is the resistance of each wire here. And so I'll just kind of grab a point off each one. It looks like this one is 0.5 and 20. And whereas the other one is 10 volts for 0.5 amps. So we can find the two resistance here. R1 is just going to be 20 voltage over current, which is going to be 20 divided by 0.5, which is 40 ohms of resistance. And then, okay, maybe that's 0.6. I don't know exactly where that is. But the next one looks like it's about 10 volts for 0.5, which is equal to 20 ohms of resistance. So that's R2. So after we know that, if we know the two resistors, we can then think about which one would be a longer wire. Remember, longer wire equals more resistance. And so the more resistance, R1, would be the longer wire. It has more resistance there. All right. So now we've got a current of 3.5 amps flows through an electrical circuit for 1 minute. Calculate how much charge. So this is where we're getting into time, charge, and current. That's that relationship between current is equal to charge, Q, divided by the time. Now remember that charge in coulombs, time in seconds. So current, 3.5 amps, is going to equal whatever charge we have divided by the time, but it's not 1 minute, it's 60 seconds, right? That needs to be in seconds. All right, and then we solve it out. So when you multiply 3.5 times 60, Q ends up being 210 coulombs of charge. All right. So E, which of the following is false? So current is protons flowing from the positive end of the battery end. While we sometimes say that current flows from positive to negative, protons are not what move. So we're thinking kind of reality here. So it looks like I is definitely not true. Current is electrons flowing from negative to positive. This is definitely what current is, the charge that flows. Electrons are what flows. Charge movement very slow. So yes, the charges move very slow, but the energy is very, very high. So those last three are all true. The first one there is the one that is false. It's not the positives, it's the negatives that flow. All right. And then finally, I believe we have kind of a proportional reasoning here. So a circuit has a current of 12 amps. What's the current if the voltage in the circuit is doubled and the resistance is reduced by 1/3? So this kind of comes from what affects what idea. So the key equation here is voltage equals current times resistance. V equals IR. All right. Now, we'll get to the 12 in a second. That'll be kind of at the end. We'll say times 12, whatever we get for the factor change. But we need to look over here what happens to the current as we change different things. So rearranging this for current is equal to voltage divided by resistance. Right? Resetting that up for the thing you want to see how it affects or change is going to be the best way to change it. And then we'll change the things that happen. So it looks like we doubled the voltage and we 1/3 the resistance. And so that is going to make it 6 times as big. And so 6 times 12 gives me 72 amps of current. And that's how we do question number 1.